What?
Still?
Yeah. You can, what?
1 o'clock class?
1 o'clock class?
No.
There's a... No. Okay. So, all right. So, let me go ahead and walk you through what your first assignment is. All right, Java. So first, I'm just going to do this the old-fashioned way simply because it's easiest. So, rabbit hunt.java. So that should compile our code. And then Java, Java rabbit hunt. All right, so this is essentially, so I've essentially given you a fully working program here. The window may not appear immediately, and that's okay. Just follow the instructions. So essentially, this is a small simulation here. We've got a fox represented by a red dot, and we've got a rabbit represented by a brown dot. Okay? The object and the way the game works, of sorts, is that the rabbit and the fox take turns moving. These green blobs are bushes. And what happens is that the fox looks for the rabbit, and it chases it down and eats it, right? If it chases it down and eats it, then the fox wins. The rabbit wants to survive 100 turns. If it survives 100 turns, the rabbit escapes, okay? Now, the fox has a specific strategy that's coded to basically, go in random directions until it sees the rabbit, and then it heads towards the rabbit. And we can walk through its strategy for you. The rabbit, on the other hand, has a very, let's take a look at its code. Public class rabbit extends animal, right? So that means, of course, that the rabbit is an animal, right? That's according to the theme of inheritance. And I've got a nice 5-page write-up for you guys that walks through all the code on this. Okay? This is just simply a constructor for it, not really anything you have to pay attention to. What you have to pay attention to is the int decide move, which is the method that you'll be working on. You only have to work on one method in this class. You only have to complete one method. Right now, you can kind of guess what the rabbit's strategy for avoiding the fox is. It says, I'm going to return a random direction, right? I'm going to decide between moving between a minimum direction and a max direction. These are just two integers that represent all the cardinal directions, north, northeast, east, and so on and so forth, right? So every turn, the rabbit decides to move in a random direction. This is not a good strategy for survival. Let's take a look at fox, on the other hand. Fox is also an animal, and it has a bit more stuff. It has instance variables, like, have I seen the rabbit? Can I see the rabbit now? How far am I to the rabbit? What direction is the rabbit in? What's the current direction I'm going, right? It's got its own constructor. Obviously, it doesn't seem to really do anything special. And then it's got its own decide move method, right? And it's basically uses all these methods here that are pretty, and it has like a look in this direction, and if look is equal to model. By the way, something interesting with my font, I'm using ligatures, so that single equals is actually double equals. It's just really long, so you'll have to note that. Also, when I do a not equals, it will appear like that. So it's just simply a feature for my font, and I happen to really like it. So, all right. So your job is to modify the rabbit so it wins way more often. Your grade will be determined by running the grader class in here, okay? And the grader, let's go ahead, and I think I have to compile that as well. Javak grader, not Java. Java grader, right? It runs the program 300 times, and then it counts how many times the rabbit managed to win. The rabbit managed to win 2 times out of 300, which was approximately 0% of the time, not even 1%, which means that the grade was a 0. Your grade on this is equal to what we call square root curve, which means that I take the square root of this and multiply it by 10. So if your rabbit escapes 64% of the time, what's the square root of 64? It's 8 times 10 is 80. So that gives you an 80. If your rabbit escapes 25% of the time, that's a 50. If your rabbit escapes 81% of the time, then that's a 90, right? So the way this curve works is that it gives a real boost to low grades and then tapers off on the higher end. Okay, it's really hard to get it to escape 100% of the time. That's fine. That's okay. If you get above 90%, I'm going to be very impressed. So, that makes it sound like it's really hard, but more like it's just that's very good. That's kind of the goal we want, and it is possible easily to get an A in this one. There's also most assignments are worth 100 points. This one's worth 120s. You get 20 for your group coming in and explaining your strategy for escaping from me. So you write your strategy, and then you also have to explain it to me. So that's essentially what you have to do. I did a write-up, but let's just go ahead and talk about all the things in here. So let's see. Hold on one second. Back to this. CD downloads, hunt, code, rm star dot class, just to clean it up. Okay. So now we've got so this is a GUI, and you've probably not interacted with GUIs before, right? Graphical user interfaces before. That's fine. This uses a very common paradigm called model view controller, and I go into detail on the write-up. We have a model, which represents basically the game and the rules. It basically controls the whole, basically the fox chasing after the rabbit looking around. What is on the board? That's what it models the actual, game. The controller, those were the buttons you were seeing. The button, the step or the run or the reset button. That's just us. That gives us the ability to control the GUI. And then the view, you can kind of guess what that is. That's us actually viewing the actual board. That's the display. The model, the controller and the view, don't worry about. And in fact, you might think, okay, this is really overwhelming. It's really not actually. The only thing you ever have to modify, in fact, the rule is the only thing you can modify is the rabbit class. You're not allowed to change any of the other code. Okay? You can only modify the rabbit class. Okay? That's the rules. Only modify the rabbit class. And okay. So what I'm trying to say is that the view and the controller, they're irrelevant to your cases. Model's worthwhile taking a look at because it helps define things like north is 0, northeast is 1, east is 2, southeast is 3. But rather than having to remember all that, right, you can just simply go model.e for east, right? Or you can go model.min direction and model.max direction and write a loop that goes over all the directions. 8 represents just staying right here, not moving. Okay. The other thing that's useful in the model, there isn't too much useful for you guys in the model other than those static methods, and I actually have a nice table in the write-up for you guys of what's useful in there. The thing that is useful is is a static turn, what we call turn method, I think. So Control F, turn. Right, turn, which basically says what is at a direct, there's this direction. What is this? What is another direction like, 45 degrees away from it? What is a direction? What is a direction completely opposite of this? For instance, if the fox is in this direction, what's the direction completely opposite? So you can use that to figure out what that is. This gives you just simply give it the direction, the number of 45-degree turns you want to go clockwise. So if you want to go in the opposite direction, which is 180 degrees, you just pass in the direction you don't want to go and 4, and that will give you the direction you want to go, right? So this enables you to, so this helps figure that out. This allows you to basically turn away from something. The other big thing is that, and I have this nice inheritance review about the way inheritance works that you should totally watch, is that all the animals here are animals, right? So the fox is an animal and the rabbit's an animal. So you've got a, so they've got a couple of methods here, look and distance, right? Which, and those are the two big ones. Look, basically you look at a certain direction, you see what's there, and it returns an int representing what's there, right? It'll return a number that represents either a fox, a rabbit, the edge of the board, right? And distance tells you how far away something is from you, right? Given a direction, how many spaces you have in that direction, right? So and then you can also figure out, can I actually move in a specific direction? Okay, so those are very useful things there. So and let me just simply run this one last time. And then give you guys the rest of the rest to start getting. And you'll basically you'll come in on Wednesday, and this is all you'll be doing on Wednesday, and possibly all in the lab. So none of this me blathering on. So it just takes a bit of administrative annoyance to get this worked up on the first one. So if I use step, you can see the fox calling move. That's what the yellow laser eyes are. That's it calling look in each direction and looking for the rabbit, right? And it did kind of skip for some reason. I don't know why it's decided to, animate over or something. But so that way you can actually see what they do in a motion. And now it saw the rabbit, so it's moving towards the rabbit, right? And now running moves it automatically, and now we see that it's going to win. Reset just simply gives you a new board, so the board is always randomly generated. So you can't just find a safe space, and camp out on it, because the board's always automatically generated. All right, any questions? All right. Initially, I've got until basically I think Tuesday for this to be done. I'll give you guys more time. So on this if you guys need it, but otherwise I think this is a pretty good assignment for starting. So go ahead and get started with it.